Hello 3D printing friends, it's time once again for another Mod Mondays video on the BV3D channel. In today's episode we're going to be taking part in a cover-up related to the Anet A8's power supply. I'll tell you more about it right after this. I'm Brian and you are watching BV3D. Hi everyone, welcome back. As I mentioned in the intro, today we're going to be taking part in a cover-up related to the Anet A8's power supply. No, I mean literally. We're going to be printing and installing a cover for the power supply. Before getting into why we're doing this, I wanted to say a couple of things. First, thanks to Mark Corliss of Corliss Media 2.0 for his support of the channel. Mark has generously covered the cost of the printer used in this episode as part of an upcoming series about installing the Klipper firmware on the Anet A8. You can find out more about Klipper in the description below. And second, a huge thanks to all of you who subscribe to the channel. It really means a lot to me to know that you like what I'm doing well enough to subscribe. And if you haven't subscribed yet, please click the subscribe button down there and also click that little bell to get notified when I release new stuff. Okay, so a lot of people may have received an Anet A8 3D printer for Christmas, and it's great that we're getting more people into 3D printing. But for a number of reasons, the Anet A8's got a bit of a reputation as an unsafe 3D printer. At the top of the list, a safety feature known as thermal runaway protection is not enabled in the printer's firmware, and we're going to cover how to enable that feature in a future episode. But another serious safety concern is the way the power cable is connected to the printer. You see, the Anet A8 ships with a power cable that has a wall plug on one end and bare wires on the other. During assembly, these wires are screwed down to the power supply's input terminals. And those terminals are exposed, presenting a shock hazard, as a stray tool or the fingers of a curious child could easily touch them. And because there's no strain relief provided, the power cable could be partially or completely pulled from the printer if, for example, you move it just a little further than the power cable can reach. If that happens, you'll have live wires out in the open with 120 or 240 volts AC, which at best would trip a circuit breaker and at worst provide a nasty electric shock. Finally, due to the power cable being hardwired into the printer's power supply, there's no power switch. You turn the printer on by plugging it in and turn it off by unplugging it. If an emergency situation arose with the printer, you'll have to find the power cable and yank it out of the wall. With all of this, you might think I was nuts to bring an Anet A8 into my house. Well, fortunately, fixing the power cable situation is really pretty easy. The Anet A8's been around for a couple of years, so all we need to do is find a power supply cover that we like on Thingiverse, download it, and print it. At least that's what I thought. But I'm guessing that Anet changes power supply vendors depending on which vendor has the least expensive one whenever they do a production run, because none of the power supply covers that I found on Thingiverse, well, that I liked anyway, would fit the supply on my A8. Eventually, I ended up modeling the power supply in Tinkercad and then designing my own cover to fit it. I designed the power supply cover to accept a snap-in power cord socket that I found on Amazon. It's got a built-in power switch and a fuse. And during my Thingiverse expedition, I noticed that several of the covers were designed to accommodate additional switches. So while I was at it, I took measurements of some inexpensive switches that I found on Amazon and made spaces for 3 of them. Now, I'm not going to go through the entire design process in Tinkercad, but it's similar to what you've seen me do before. Let's go get into Tinkercad and I'll show you a couple of the tricks that I used when working on the design. Okay, here we are in Tinkercad looking at the power supply model and the cover. You'll remember that I said Anet seems to use different manufacturers for their power supplies, so the one I have may not be the one you have. In order to get an accurate model of the power supply, I had to remove it from the printer. After that, it was simply a matter of taking measurements with my calipers and making boxes of the appropriate size. There is one screw hole on the side of the power supply, and we'll use that to hold the power supply cover in place here. There is a second screw that actually holds one side of the power supply's circuit board in place, but we're going to use that to hold the cover on. We're going to use a slightly longer screw and it'll go through this hole here. One benefit of having the power supply modeled in Tinkercad is that it enabled me to perform virtual test fits of the power supply covers that I downloaded from Thingiverse. I could import the STL files into Tinkercad and see right away how they fit, or in most cases how they didn't. It's just a matter of pulling the file in and aligning it. Usually I would make it transparent, and then I could switch to a top view and see if I was getting it lined up right. In a lot of cases, it wouldn't line up. Either the supply cover was too narrow, or it was too wide, or it only attached at one point. Others required you to drill holes in the power supply case, and I wasn't going to do that. I just wanted something that I could print and bolt into place. Well, let's make this non-transparent again. I'm going to move the power supply cover out a little bit so we can take a look at it. All of the switches simply snap into the cover, so it was necessary to take measurements of the switches and design cutouts to accommodate them. There were two things that I had to take into consideration for the switches. First, I needed to ensure that the size of the opening would allow the switch to be fully seated. And second, I had to make sure that I could accommodate the locking tabs on the switches so they would stay snapped in. The easiest way to do that was to make a sort of a hole punch, and of course that'll be a hole object in Tinkercad. Then I can position that anywhere on the power supply that I wanted to have one of those switches installed. In the case of these on-off switches, I've got a couple of boxes that I used to make the cutouts. I'm going to change the color on this so I can refer to it. Make that yellow. So this red box is the one that does the main cutout for the switch. And I took measurements of the switch and simply designed this to accommodate that size. The yellow box represents the material that we're going to remove to accommodate the locking tabs. And you'll notice that it doesn't go all the way down to the surface here. And that's because we're leaving some material in place. We're just pulling some out to give that locking tab a little place to bite. So the way that ends up looking over here is that we've got this little notch. And so the locking tab can sit in that notch and it'll hold the switch in place. So just to demonstrate that, I'll go ahead and flip the power supply cover over. I'll group this together and turn it into a hole, and I'll drag it over here. Let's say we wanted to install a switch there. I can group that hole with the power supply cover, and then magically it makes a cutout for me. I'm really not going to leave the switch here. I'm going to undo that, and I'm going to remove that. Okay, well I've already got the power supply cover exported, so let's switch over to a slicer, slice it, and then start it printing. Now here we are in Slicer Prusa Edition. I'm going to drop the power supply cover model in here, and then I'm going to rotate it 180 degrees. I just want to get a better look at it. Now I'm going to slice this to print at a 0.2 millimeter layer height, not at 50 millimeters per second, but at 150 millimeters per second. I've got my Sunlu grass green PLA loaded. And I'm choosing this ridiculously high print speed because I've got Klipper installed and I want to see how this is going to turn out. Okay, let's export that. And then drop it into Octoprint on the Raspberry Pi that's also hosting Klipper. And we can get the print started. Just a quick note about Klipper. It's firmware that runs both on the printer's control board, the MCU or microcontroller unit, as well as a Raspberry Pi. The part that lives on the Raspberry Pi makes use of the extra computing resources available there to plan out the moves needed to produce a print, and it communicates with the MCU to actually carry out the movement commands. You can learn more about the Klipper firmware in the description below. Now, in theory, Klipper should allow us to print faster, although on a stock Anet A8 with its not entirely rigid acrylic frame, the faster prints are likely to be less accurate. Now the first layer is only printing at about 20 millimeters a second, and I always do my first layer slow. But check this out when we start getting into layer 2. The more room it's got to make a move, the faster it goes. You can hear that thing accelerating and decelerating. If this was just a big flat part without all those cutouts, it would just be flying through it. Well anyway, I just wanted to show you that because it's kind of cool. Let's go ahead and get into the time lapse now. All right, now that this thing's done, we're going to take it off the printer so we can put it on the printer. You know what I mean. We're going to move up to the workbench upstairs where I've got some room and we can spread out. And here we are up at the workbench. I've already removed the power supply from the printer. And that was just a matter of removing the wires from the input terminals and removing the 3 screws that hold the power supply to the frame. Now let's go ahead and get this print off the bed. I installed one of those flexi floppy magnetic build surfaces for the printer. And in general, I like them. This particular one, I really can't recommend. I thought I was going to like it because it had these handy cut lines for different bed sizes, so I could cut it to size. But whatever ink they used on this tends to stick to my prints when I take them off. At least this time it didn't, so I'm grateful for that. The Creality Cmagnet sheets don't really have that problem, so if you're on a really tight budget and you want to try an inexpensive removable build surface, give the Cmagnet a try. They're about 18 bucks on Amazon. And if you've got a little bit more in your budget, I highly recommend the Wham Bam Systems Flexible Magnetic Build System. It's built around a spring steel sheet, so it's not floppy, and the PEX or PEX print surface holds onto the filament really well during the print and releases easily when the print's done. Links for both of those are down in the description. Well, all right, now that we've got the power supply cover off the printer, let's get the switches wired up, installed, and get it back on the printer. Well, all right, let's take a little closer look at the part. For printing at 150 millimeters a second, I think it did really well. The Z is a little bit not 100% aligned, but that's all right. This is just a rough part. I've got a little bit of under extrusion here, but that's really not going to affect what I'm doing. So I think we're good. I think this will be okay. All right, let me set this aside and we'll start working on the wiring. This is our power input cable that came with the Anet A8 with the bare wires on it that I really don't care for. I'm going to cut a length of this off and we're going to use the wires to get this switch wired up to the power supply. I'm just going to pull these out. All right. Okay, so that power input cable follows the IEC wiring color code. So the yellowy green wire is ground, the blue wire is neutral, and the brown wire is the hot wire. So we're going to be putting some of these little spade lugs or spade terminals on the ends of these wires so that we can snap them into the switch, because this uses those little spade connectors on here. Now, because the brown wire is the hot wire and we only have a single pole switch on this, we're going to be switching hot. So I'm going to cut this in half and we're going to use part of it for wiring the switch and the other part for taking the output of the switch over to the power supply. So what we're going to do is we're going to strip some wire off of the ends of each one of these, probably about a centimeter. And as you strip them, you give them a twist. Make sure that all the little strands stay in place and you don't have any little stray bits poking out. Okay, so we're going to take these and we're going to crimp the connectors on. And the wire, the bare wire, just goes down in there. And then we take our crimping tool and we crimp it in place. And as you crimp each one of those, give them a tug and make sure you've got a good connection. On the wires that come from the switch and go to the power supply, we're going to use these spade terminals. These are the same kind of connectors that Anet uses to send power into the main board from the power supply. So here's how we're going to wire up the switch. This terminal right here is ground from the power input. So we're going to plug this connector in here. This is the green and yellow wire, that's ground. This lead is neutral, so we'll use the blue cable, we'll plug that in. And this lead is hot, and so we're going to route that over to the switch. And then we're going to take the output of the switch, and that will go to the power supply. There we go. All right, now we need to take this switch assembly that's all wired up and snap it into the power supply cover here. There's one. And let's get those other little switches and snap them in too. And there we go. There's all our switches. Now, these 3 switches aren't used for anything right now, but I've got plans for them. There's room in here for me to mount a buck converter, so I can take the power supply's 12-volt output,
step it down to 5 volts for a Raspberry Pi and still have enough current to drive it. And that'll be on one switch. And then I want to add some lighting, similar to what I've done for the Monoprice Maker Select Plus printers. That'll also use 12 volts, and that can be here. And then finally, I thought about maybe installing an LED on the extruder itself so that I can light that up and not have to use a flashlight when I am watching that first layer print. So that'll be this switch. Now we're going to get these hooked up to the power supply. You may be able to just barely see here that these are marked. The first terminal is line, the second is neutral, and the third is ground. So we're going to connect these up. Our ground lead is the yellow-green one, so we'll get that installed here. Neutral is blue. That'll go here. And the line, or hot, goes here. All right, let's get these other leads connected. The first 3 here are ground, so we'll get the ground lead connected. And the next 3 are 12 volt, so we'll get the 12 volt line connected. And that's it for the connections. Now we need to get the power supply cover bolted onto the power supply. I've removed the screw from the corner of the power supply here, and then we have the screw hole on this side here. And the power supply cover will bolt onto those 2 spots. Now we can mount the power supply back onto the side of the printer. Okay, we've got a standard power cable. Let's plug that in here. Our switch is off. Let's turn it on and see if we release magic smoke or if it works. And there we go. Awesome. It's happy. Well, okay, that wasn't so bad. Now we can turn the printer on or off with the flick of a switch. So this takes care of one of the safety concerns with the printer. In the next few episodes, we're going to cover installing a bootloader on the printer's MCU, installing updated firmware on the MCU, and other fun stuff. There will be separate videos covering the installation of Marlin and Klipper Firmware. Either one of those will allow us to enable thermal runaway protection, which is a very important safety feature. There are also a couple of Octoprint videos in the works, so if you haven't subscribed and clicked the bell icon for notification, you might want to do that now. The Anet A8 can sometimes be a controversial printer, mostly because of its lack of safety features. Nobody wants a printer fire. And frankly, for about $40 more, you can get a Reality Ender 3, which has an aluminum extrusion frame instead of acrylic and hasn't been accused of starting fires. On the other hand, if you really like tinkering with things and learning how they work, the A8 can be an inexpensive starting point for learning about 3D printing. There are a whole host of modifications you can print for it, and rest assured, there will be several of them featured here. But seriously, for safety's sake, until you have thermal runaway protection enabled and an easy way to turn the printer off, please do not let an A8 run unattended. So what's your opinion on the A8? Is it a hazardous product that shouldn't be bought, or is it an okay starting point for 3D printing as long as you take care of the safety issues? Or is it more of an intermediate level printer, something you'd use to get more in-depth knowledge of how a 3D printer works after having started with a less DIY printer? I mean, with the A8, you start with a box of parts and pretty much build it up from scratch. I'm curious what you think about it, so let me know down in the comments. That's about all the time we have for today. I hope you enjoyed the video, and if you did, please give it a thumbs up, and if you didn't, give it a thumbs down. But either way, comment and let me know what you liked or didn't like. If you like the content I'm producing and you'd like to support the channel, you could buy me a coffee or maybe leave a little something down in the PayPal tip jar. Links for both are down in the description. Thanks again to Mark Corliss of Corliss Media 2.0 for his support, and a big thank you to all of you for subscribing to the channel and watching and sharing these videos. Well, now that the A8 has its power supply cover installed, I'm going to go print something cool. I want you to do the same, and I'll see you next time.